So in this case, what's the probability of being between the mean itself and 0.45 standard deviations below the mean? So I'll take a moment and do that one.
In the previous class, 2 and 5, our professor gave us a packet that had the different sides of standard deviations. Could we use that if you wanted us to use the standard deviation? So it's basically like we had a side of the standard deviations like that, then we had it on the other side, and then it had all the probability there.
Oh, okay, so it had like above and below. And you could use that. I mean, they're going to give you the same answer.
Okay.
So you could do that. I mean, so if you feel comfortable and remember that technique, that's perfectly acceptable.
Okay.
What I would give you, for example, on a test, though, would be this chart.
Okay.
So, okay. So let's go through this one. This one actually turns out not to be difficult at all. In this case, again, we can draw this up. So again, we have our mean of 0 here. And in this case, we're looking at the probability of being between the mean and 0.45 standard deviations below. So I'm going to put 0.45 there, negative 0.45 there. And so the area I'm looking for is this area right here. Now, we're going to use one piece of information that I gave you. The piece of information we're going to use is this one, the bell-shaped symmetrical rule. In this case, you're equally likely to be above or below the mean. So the probability of being between the mean and 0.45 standard deviations below the mean is exactly the same as being between the mean and 0.45 standard deviations above the mean. So in this case, you actually don't need to do any additional calculations. I heard one person say you should subtract 1. Don't need to do that, although we will be subtracting 1 at another point. But in this case, what you want to do is just look up 0.45 in the chart, and that's going to be your answer, because the probabilities are exactly the same of being below as being above the mean. So in this case, we look up 0.04, go across to the 0.05 column, and in this case, what we get is we get an answer of 0.1736, or 17.36%. Any questions about this one? Everyone feel okay with this so far? Well, we can do some things that are a little bit different. We could do what's the probability that C is greater than 1.96? So what's the probability that C is greater than 1.96? Now, I will tell you in statistics, 1.96 is a magic number. One time my wife questioned me, or I was paying something to my parents, and it was like $196, and my wife said, why didn't you just make it $200? I'm like, because 1.96 is a special number, and she rolled her eyes at me with that. You're a statistician, aren't you? Because only you would be geeky enough to say 1.96 is a magic number, so we should use it. But it is. So take a moment and try and figure out this probability. What is the probability of being more than 1.96 standard deviations above the mean? We have to do a little bit more than just the chart. The chart will definitely, you need to do one other thing beyond the chart. And this chart will answer any probability question I give you. Let's start working on this one. So again, what we should do is graph out what we're looking for. So in this case, what we're looking for is what is the probability of being more than 1.96 standard deviations above the mean. So here's 0, our central tendency. Here's 1.96, somewhere above it. And we're looking at the probability of here from 1.96 and being above it. Now, if you look at your chart doesn't give you this upper tail region, which is what I'm looking for here. Our chart only gives us the area between 0 and a z-score. So one thing we could find is we could find out what's the area between 0 and 1.96. So we could find out what is the probability of being between the mean and 1.96 standard deviations above the mean. So if we look up 1.96 in our z-chart, we find a value of 0.4750, or 47.5%. So the probability of being between the mean of 0 and 1.96 standard deviations above it is 0.4750. But the way we can have this information help us is, again, if I go back to symmetrical, I know that you're equally likely to be above or below the mean. Part of being symmetrical means that you're equally likely to be above or below the mean. So in this case, that tells me the probability of being above the mean is 50%. It also tells me the probability of being below the mean is also 50%. So I'm equally likely to be above or below the mean, so I know the probability of being above the mean is 50%. Probability of being below it's 50%. So I know the area from 0 on up is 50%. I know the area from 0 to 1.96 is 0.4750.